Um, Hello, good people. Um, so calculus for machine learning এই জার্নিটাতে আজকে হচ্ছে আমরা নামপাইয়ের কিছু আহ, জিনিসপত্র দেখব বেসিকলি differentiation based. I'm a bit sick, so maybe আমার ভয়েস একটু অদ্ভুত শোনাতে পারে. So anyway, moving on. Today we are going to um, learn differentiation in Python, like symbolic, numerical, or automatic, and we will explore. Um, we will see uh, tools or library which is available for derivative computation. In okay. So for symbolic differentiation, uh, this is the method or basically is called simpy, and then for numerical it's numpy, and automatic that's pronounced as jax, I guess. We will look into that later. So now moving on, we will see how to define function in Python. So suppose we have a function, f of x is equals to x square. uh, I'm a bit sick, I mean একটু a bit feverish. আচ্ছা, anyway, so wait, why it's not working? অদ্ভুত তো। আচ্ছা, so আচ্ছা, by the way, I think um the thing is, the video maybe, the real time process is very um bit, I mean normal speed, but when you see my video, you can watch it in 1.5x or 2x, or 1.25x. So okay, so suppose we have a function, Allah. Okay, so we have f of x is equals to x square. This is uh suppose we have function, so we are defining f of x, and the value will be returned. I mean the function, I mean the value that function will output actually, so that is x to the power 2. So মানে, I mean, in Python কোনো কিছু আমরা পাওয়ার দিয়ে লিখতে গেলে, like suppose this one, so it is written as, I mean the syntax is like, this is very basic, we all know that. So this is the syntax, and then basically then we are printing. So this calls function and then print the result. So this gives us 25, because 5 to the power 2 হচ্ছে 25 square. Okay, so then function in Python, so we can find derivative of function analytically. আচ্ছা, এখানে বেসিক্যালি অ্যানালিটিক্যালি দেখাচ্ছে, যেমন হচ্ছে আমরা x, what we know, like the derivative of x square is 2x, right? So basically ওই 2x টাই রিটার্ন করতেছে and that we're saying it gives us 10. Okay, then with numpy, so this is import numpy as np. So basically we are importing a library of python as np because মানে আমরা হচ্ছে np দিয়ে হচ্ছে অ্যাড্রেস করব পরবর্তীতে শর্ট করে। So this is our variable, it's arr I have taken. So np dot array, so basically we are creating a array here যেটার element হচ্ছে 1 2 3 and oh, it's raining outside. Okay, so and then these are the ways that we are printing, you know. So first this is printing the list 1 2 3 and remember um we made a function here. So basically we are using this here. So this is the concept of function. So I hope you everybody know about this. So if you don't, if you're unclear, then you have to clear your Python basic first and then you can watch it. Anyway, so I mean you can look into the function topic. So moving on, this is j slash n. So this means this will print in the next line. This is the syntax. Okay, so that's how it's being printed. Then moving on. Okay, so here is the code that is we are using matplot library and um, this the first line here. This imports matplot lib.py plot as plt. It's a module যেটা used হয় for create a plot and the visualization in python. Okay, so next moving on, আমার গলা একটু বসে যাচ্ছে, never mind. So defining plot f1 and f2. f1 f2 আমরা ধরে নিচ্ছি হচ্ছে none. So this is the function part and this all our parameter here, and this line defines a function. Okay, this line uh, so f1 here, this is first function to plot. F1 here, it's indicating our first function to be plotted, and f2 হচ্ছে second function or array if we take array. And we initially we are like assuming it's defining is as like defaults to none, and then we have x minimum and x max. So minimum and max value for our x axis, and then we have the parameter label 1 and label 2. uh Label 1 and label 2 here. So these are the label for plot 1, sorry, plot f1 and plot f2. So next line in the line number 7, we are creating a array x of you know 100, like it's 100 here, so 100 evenly spaced points between x minimum and x max using this np dot lean space or line space, whatever it's called. um and aj np dot lean space, this is our function. So now we are going to setting the axis at the center. So first line we have fig equals to plt dot figure. So this is basically we are creating a blank canvas for our plot, and then we in the next line it is this adds this 111. So this adds a single subplot to figure which will occupy the entire figure. So 111 parameter indicates subplot grid, which is 1 into 1, and we are referring to first subplot only. And এখানে যে ax dot spines, এখান থেকে একদম till top and none আর কি তো basically এই যে the first line here left and dot set position center. So it basically means the positions in the left spine, I mean y axis at the center of the plot. So basically আমরা সেন্টারে y axis কে position করতেছি, and in the x dot spines bottom and 0. So this means 0 value te we are setting up the x axis, and the next two line right and top. So I mean this two line, so these are basically uh removes right and top spines by setting them color to none. কালারটাকে হচ্ছে আমরা নান করে দিছি, so this will be removed. And next two line, like line number 16 and 17, um, this ensures that the tick appear only on the bottom and left spine, I mean the axis. Okay, and so basically from line number 10 to line number 17, these are about setting up plot axis. And now moving on, okay, so we have plt dot plot x. Here basically for array x, this line plot function 1, মানে x অ্যারের জন্য আমরা f1 কে হচ্ছে f1 যে প্লটটা ওইটা বেসিক্যালি মানে ফাংশন f1 যেটা, the function f1 we are plotting that. So this is plotting the functions, and here the f1 of x is basically like লেখা হয় না কেন? আহ, okay, so f1 of x হচ্ছে this is line number হচ্ছে line number 19. Okay, so f1x হচ্ছে compute value of f1 at each point in x, and r means this basically specifies that color will be red Acha. And we have also label equals to label 1. So this basically means মানে, this basically assigns a label to this plot. For use in legend and with default value being f of x. Okay, then we have a if condition here, that if not f2 is none, which means if f2 is provided, মানে আমাদের যদি f2 টা দেয়া থাকে, so if is instance f2 comma np dot nd array. So basically here we are checking if f2 is a numpy array. That is what we are checking in line number 23. Then plt dot plot. Okay, so in line number 24, basically if f2 is array, then it's plotted as blue. মানে আমার f2 টা যদি হচ্ছে like we have mentioned before, like our f2 can be an array or it can be um so acha, okay. And then if I mean if I'm sorry. So if f2 is an array, so it's plotted as blue, like um b. And um if f2 is not array, it's treated as function, and f2 of x is plotted as blue line. Okay. Or now we have a else here. Okay, so then we have plt dot legend. So this line adds legend to plot using a label specified for f1 and f2. And lastly, in this line, in this line, we are basically calling the function here. So yeah. So after working on it, hold on a second. Okay, so at last this is giving us, see, the y-axis and the x-axis and the blue line and the red line. So basically the blue line is indicating the derivatives line, and the red line is our function. Okay, so basically if I sum up, This code basically defines a function which is plot f1 and f2. This function যেটা হচ্ছে takes two functions or a function and the array and plots them on same graph, যেটা হচ্ছে আমরা মাত্র দেখলাম, and the axes are customized so that x-axis is at 0 and y-axis is at center. X-axis is at 0 and y-axis is at center, and um, which helps in visualizing the function's behavior around the origin. So this plot will display a function f of x and its derivative f prime of x that we have just seen on same graph with different color and label. আমার গলা বসে যাচ্ছে. Okay, so moving on. Our next topic is symbolic differentiation. So symbolic differentiation basically kind of mathematical objects computation. I mean, it deals with mathematical objects computation, which represents exactly, like, not the approx value. As in, let me suppose it will show, if you have root 2, it will show root 2. It will not give you, 1.414, etc. It will not give you this. It will give you this root 2. Okay, so the first thing we have is introduction to symbolic computation with SymPy. So for this we use one of the libraries that is, of Python, which is SymPy library. So for calculating approx decimal value of root 16, uh, sorry, it will be 15 here. Okay, it can be done normally. Like, we can do it with this sqrt function, right? Calling the squirt function from the math module. First আমরা হচ্ছে math import করে নিচ্ছি মডিউলটাকে, which is built in module. সেখান থেকে আমরা হচ্ছে sqrt ফাংশনটাকে আমরা we are accessing. So thus we are, like, normally or manually calculating the square root of root 15 basically, and this is giving us, these points, but with using SymPy these are only simplified, like this doesn't give us this number as we have seen here. So it's give us 3 root 2 in a root form basically. And here one more thing, so the way we have written it here from SymPy import and we added a star here, so this basically SymPy dot sqrt function, but here the SymPy prefix is omitted, মানে সামনের SymPy যে প্রিফিক্সটা ওইটা ইউজ করা লাগতেছে না, দেওয়া লাগতেছে না আর কি. So এই যে this format of module import allows us to use SymPy without using SymPy prefix. Okay, so list of symbols in SymPy. Variables are defined as symbol. They need to be predefined. Okay, let's see. So here we are, defining it xy. We are defining it as symbol, and we are setting up an expression, kind of variable. Um, basically we are uh, defining a equation here. Then so we wrote a equation here, and this exp are basically this displays the value of the expression. এখানে যে আমি এটা লিখতেছি এটাই হচ্ছে আমাকে প্রিন্ট করে দিচ্ছে। See 2x square minus xy. Okay, then we can expand it with the expand function. So this is a function, and oh, acha, sorry, I missed it. Now by using this expression, we can manipulate it with. I mean to say, um, suppose we have basically that we had taken here. So we are now working on it like this thing, like the equation we created, so that we are using it here. See, and creating another new expression here. So basically this gives us x into x cube plus 2x square. And we can expand it with the expand function. Basically expand bolte we all know that, like uh, x into x cube is x to the power 4, and x into 2x square হচ্ছে plus 2x cube. Okay, then we factorized it with, basically we are seeing different operation or function here. So we are factorizing it like factor expression, so it's being factorized. Okay, to substitute particular values for the variables, I mean, if you set up a given value, like your wish, so for this we have the evolve evolve function, sorry, method. So this is a method from SymPy that evaluates the expression to a floating point number. So it computes the numerical value of the expression after substitution. So here we are adding the value. So this is a dictionary that specifies the substitutions to be made. So যেটা আর কি, like x will be replaced with, I mean the value assigned with -1, and y will be 2 here. And then when we are using this method, so it's আমরা value দিয়ে দিচ্ছি, we're giving value here. It worked on this যেটা আমরা হচ্ছে বের করছিলাম, এই যে this one. So it worked on this and thus gives us minus 1.0 after the calculation. Okay, so this can be used to evaluate a function f of x equals to x to the power 2 minus x square. So suppose we are taking a function like x square, and then আমরা হচ্ছে we are putting value of x is 4, thus 4 to the power 2, which means 4 square gives us finally 16. Okay, so now we will see making a symbolic function numpy friendly so that it can be evaluated for each element in numpy array. So first we need to understand symbolic expressions and numpy arrays. Basically, we are kind of trying to make a relation between them, something like that. So um first we are defining a symbolic expression here, like the previous one we defined, I mean the equation, if I um say in easy language. Okay, and then let's take a numpy array that we also had taken before, একদম শুরুতে, remember this? Okay. uh so basically the problem here is direct evaluation of symbolic functions on numpy arrays. So numpy array উপরে we will মানে direct evaluate of symbolic functions. So in SymPy, symbolic expressions are typically evaluated with specific values of variables. However, if we try to evaluate a symbolic function directly on a NumPy array, we will encounter issues. So basically, if we straight try to use symbolic function on a NumPy array, so we will get, মানে basically আমরা what we are doing previously, we were doing things on the expression, right? But now we are trying to do it on array. So ওইটা করতে গেলে so when we are going to do that, we will encounter issue. So here's the code that will cause an error. Okay, এইটাকে আমি কমেন্ট আউট করে দিই। So আচ্ছা, let me give you a tip, you know. So এই যে আমি যে I have uh, made this four line together with commented out. um okay, so let us explain this. So here we took if I mean that function, we are taking array into that, and this line attempts to evaluate the symbolic expression using a numpy array as an input, and we will get a type error because SymPy symbolic functions are not designed to operate directly on NumPy arrays. But basically, we will not be able to directly use symbolic functions on NumPy arrays. So, which expect element-wise operations, SymPy expects single numeric inputs rather than arrays. Okay. So making the function numpy friendly. So here lambdify work as a bridge. So resolve the issue, we need to convert the symbolic expression into a function that can handle numpy array, which is lambdify. And this is the syntax. Okay. So lambdify is basically a function from SymPy's utilities, যেটা হচ্ছে কনভার্ট করে সিম্পল এক্সপ্রেশনকে into a function which can be evaluated with numerical inputs. So it can generate a function compatible with numpy, so allowing you to apply the function element wise on numpy arrays. So basically here we are converting the symbolic function lambdify. So age we are taking lambdify x f of my, I mean that function and numpy ফাংশন বলতে আমি কিন্তু ম্যাথের ফাংশনও বুঝাচ্ছি। ওকে, সো এই যে সিম্বলিক এক্সপ্রেশনের যে এফ সিম that we had, it turns it into a function that works with numpy arrays. Okay, and the argument like x here. So this the variable in symbolic expression you want to substitute. Are this one is the symbolic expression that we want to convert actually. And numpy specifies that the generated function should use numpy for numerical computations. And this is the result, new function that behaves like a numpy friendly version of f, I mean this one.